At 37 minutes past 11, universal time, while a billion-ton cloud of solar plasma was still crashing into the Earth's magnetic field, the floor of the southern Philippines tore open and the strongest earthquake of the entire year began. A magnitude 7.8, on the same day a strong solar storm was forecast to hit, 2 days after a moderate one already had. And here is the part that should make the hair on your arm stand up. The flood of particles from the sun peaked the day before the ground broke, exactly the offset some researchers say should come before a great quake. Tonight we are going to lay the sun and the seafloor side by side and ask the question almost nobody is asking out loud. Was it a coincidence, or was the Earth answering the sky? If questions like that are why you are here, take a second to subscribe to the Sky Lab, because this is the story we follow every single day, the moment the world above us and the world beneath us collide. Drop a comment and tell me where you're watching from, and whether you felt this quake or saw the auroras this storm brought. You will want to be here for what the data actually shows. Now, let's get into it. Part 1. The strongest shock of the year. At 37 minutes past 11 universal time, the floor of the southern Philippines stopped being solid. For somewhere between 60 and 90 seconds, the ground beneath the island of Mindanao did something the human body is not built to stand through. It heaved, it rolled, it threw people off their feet and emptied swimming pools and peeled the panels off the sides of buildings, and when it was finally over, the strongest earthquake recorded anywhere on this planet so far, in the year 2026 had already written itself into the record, a magnitude 7.8. And here is the first strange thing about it, the thing we're going to spend the next 2 hours circling like a question that refuses to be answered. It did not happen on an ordinary day. It happened while the sun was in the middle of a storm. I want you to understand from the very first minute what this video is and what it is not. This is not a video that is going to tell you the sun reached down across 93 million miles of empty space and shook the ground in the Philippines. I am not going to make that claim because the honest science does not support that claim, and I respect you too much to hand you a thrilling story that falls apart the moment you poke it. But this is also not a video that is going to roll its eyes at the question and move on, because the timing of what happened today is genuinely, almost uncomfortably striking, and waving it away would be its own kind of dishonesty. What this video is a long, patient, two-sided look at one question. The strongest earthquake of the year struck while the sun was throwing storm after storm at us. Is that coincidence? The kind of meaningless overlap that a busy planet and a busy star will produce by pure chance? Or is the Earth, in some way we have glimpsed in the data but never proven, answering the sun? Hold that question. We are going to earn an answer to it, or at least earn the right to understand why there is no clean answer yet. Let me show you what we actually know, because the very first numbers tell you something about how chaotic those opening minutes were. When a great earthquake happens, the machines that measure it do not get a clean answer right away. They get a first glimpse, a fast automated estimate squeezed out of incomplete data in the space of a few minutes, and that first glimpse came in high. The early solutions ran as large as 8.1, 8.2. For a few minutes, the people watching the feeds were staring at a number that crosses the line into what we call a megaquake, the informal threshold being magnitude 8.0, and a megaquake is a different animal entirely. Then, as more seismometers around the world reported in, and the full shape of the rupture was solved, the number settled. The United States Geological Survey put it at 7.8. The international agencies landed in a spread around that figure. Australia's network read it near 8.0. Germany's read it near 8.1. Indonesia's read it near 7.9. Everyone agreed on the same basic truth from slightly different angles. This was enormous. Now you might look at that and think, 7.8, 8.2, what is the difference? Those are almost the same number. And I understand why it feels that way. The two figures sit right next to each other. They look like neighbours on a street. But this is one of the most important things to understand about earthquakes, and we are going to come back to it again and again tonight. So let me plant it now carefully, because almost everything that confuses people about earthquakes flows from this one misunderstanding. The scale we use is not the kind of scale you're used to in daily life. It is not like temperature, where 80 degrees and 84 degrees feel almost the same. The magnitude scale is what mathematicians call logarithmic, which is a fancy way of saying that each step up the ladder is not an addition but a multiplication. Each whole number is a massive leap in the size of the waves, and an even more massive leap in the actual energy released. So the distance between a 7.8 and an 8.2 is not small. It is roughly an order of magnitude in the actual energy released. The numbers look like neighbours. The energy behind them lives in different worlds. So when the figure slid downward from that frightening preliminary 8.2 to a final 7.8, that was not a small correction. That was the planet telling us it had, in a sense, pulled its punch. And we are going to find out later in this story that some people did not see it that way at all. Some people saw that revision and decided it was a lie, a deliberate downgrade, and the reason they decided that turns out to be one of the more revealing threads in the whole event. But hold that thought, because before we argue about what the number means, you need to feel what the number did. Numbers on a screen are easy to scroll past. The reality on the ground is not. Picture a fast food restaurant in the southern part of the country, near the epicenter, the kind of place that is always full because people genuinely love it there, a place where on any given afternoon there are families and children and workers on their break. In the footage that came out, the whole building simply comes down. Not a wall, not a corner. The structure folds in on itself. Picture a vehicle dealership, glass and steel crumpled. Picture a multi-story residential block reduced to a heap of concrete and rebar. Picture a high-rise still standing but cracked at the foundation, the kind of crack that means engineers will walk up to it, study it, and quietly decide the building can never be occupied again, that it will have to come down on purpose because it can no longer be trusted to stand on its own. Picture a shopping mall, and as the shaking builds, the side panelling starts to shear off the exterior and fall away in sheets, while a man in the frame cannot even keep his footing, lurching, grabbing at the air. Picture a swimming pool, and the water is not gently rocking the way it does in a small tremor. It is slamming from one end to the other so violently that within seconds the pool is nearly empty, the water thrown clean out over the edges and across the deck. That last detail, the pool, tells you something specific, and I want to pause on it because it is the kind of thing only an eye trained on earthquakes notices. When you see a pool video from a small earthquake, you get a little sloshing, a gentle back and forth, water lapping at the tiles. When you see a pool nearly empty itself in seconds, you're looking at the signature of something much larger. Because here is what scales up as an earthquake grows, and it is not what most people assume. It is not only that the shaking gets stronger, it is that the shaking lasts longer. A magnitude 5.5, a magnitude 6, that is maybe 5, 10, 15 seconds of motion at the very most, a hard jolt, and then it is over. What hit Mindanao was far longer than that. Long enough to throw a pool empty. Long enough that people in the videos cannot stand, cannot run, can only hold on to whatever is nearest and wait for the world to be still again. Duration is the secret signature of a great quake. The bigger the rupture, the longer the fault takes to tear, and the longer the ground keeps moving. And the duration here was severe, and the damage was not only the buildings you could see fall, there was a quieter kind of disruption rippling through the systems we depend on, without ever thinking about them. The electrical grid in Sarangani province tripped itself offline automatically. That is a designed behaviour, a protective reflex, the grid sensing violent ground motion and pulling its own breakers to keep the infrastructure from tearing itself apart, transformers and substations shutting down rather than risk being destroyed. The side effect, of course, is darkness, and a lag in telecommunications across the region, right when people most needed to reach each other, right when families were trying to find out if their loved ones were alive. The airport at General Santos suspended operations, and in a detail that is almost poetic in how it captures the raw force involved, one of the seismic monitoring stations inside the Philippines, a machine whose entire job is to record earthquakes, was knocked offline by the largest aftershock. Think about that for a second. The instrument built to witness the shaking could not survive the shaking. The watcher was thrown from its post. And I want to say something about the place itself, because it is easy, watching footage of collapsing buildings on a screen, to let a disaster become abstract, a news item, a number. The southern Philippines is not an abstraction. It is home to millions of people, cities and towns and villages full of ordinary lives, markets and schools and churches and the restaurants people love. When that fast food restaurant came down, it came down on a place that was, on an ordinary afternoon, full of the most ordinary human activity imaginable, people eating, talking, living. The reason I keep returning to the human detail rather than staying comfortably up in the physics is that the physics only matters because of the people. The fault does not care about the magnitude scale. The scale exists for us so that we can understand what happened to us. So as we go deep into the science tonight, into trenches and flux and the strange question of the sun, I want to keep one foot planted in the reality that this is, first and last, a human event, and that somewhere tonight families are searching rubble for people they love. Everything else, all the speculation and the wonder, sits on top of that. So that is the ground. That is what broke, and how hard, and what it began to cost. The full casualty picture we will come to, and I will be honest with you about it, because the honest version is harder than the version you will hear in the first day of any disaster. But for right now, I want you to sit with the basic fact and the basic strangeness side by side, because the entire rest of this video lives in the tension between them. The strongest earthquake of the year, and the sun, 93 million miles away, in the middle of throwing storm after storm across the gap toward us. 2 days before this rupture, a geomagnetic storm had already struck the Earth and wrung our magnetic field. Within hours of this rupture, another, stronger one was forecast to arrive. The planet and the star were both, in their own ways, going off at the same time, on the same day, and almost nobody was talking about the two events in the same breath. We are going to. Is that a coincidence? It might be. It very probably is. I want to be straight with you about that from the start, so you never feel like I am leading you somewhere I have not earned. But before we can even ask the question properly, before we can decide whether the sky had anything to do with the seafloor, we have to understand exactly what kind of break this was. Because the kind of break it was, the precise way the rock moved deep beneath the ocean floor, is the first real clue in everything that follows, and it is going to explain something that, on a day with a magnitude 7.8 earthquake near a coastline, should have been a catastrophe and somehow was not. Part 2. What a reverse thrust really is. There are only a few basic ways the Earth's crust can break, and the difference between them is the difference between a quake that drowns a coastline and a quake that merely shatters it. So let me give you the one that matters here, slowly and clearly, because the southern Philippines did not just have a big earthquake. It had a specific kind of big earthquake, and that specificity is going to explain one of the most important things about the whole event, which is why the tsunami that everyone feared, the wave that should have come, mostly did not. This was a reverse thrust earthquake. Let me make that physical for you, because the term sounds technical, and the reality is something you can feel in your own two hands. Hold up your two hands flat, one over the other, palms down, like two slabs of rock lying one on top of the other. Now imagine they are being squeezed toward each other from the sides, compressed, crushed together by enormous, unrelenting force. Something has to give. In a reverse thrust, what gives is that one slab is suddenly driven upward and forced up and over the other. It is not a sliding past side to side, the way the famous California faults move, where two blocks grind horizontally against each other. It is a shoving up and over, a vertical lurch. The rock that was being crushed for years, for centuries, suddenly releases all at once by thrusting one block toward the sky. When scientists crunch the waveform data from an event and produce what's called a moment tensor solution, a mathematical description of exactly how the fault moved, they get a precise picture of that motion, and for this earthquake both of the possible solutions told the same story. The fault was dipping at around 45 degrees, halfway between flat and vertical, a clean diagonal. The motion was almost purely that compressional thrust, up and over, with only the faintest sideways component, the smallest hint of oblique slip. This was, in the cleanest sense, the crust failing under pressure by lifting itself toward the surface. Now here is the number that quietly governs everything else about the day, the single most important figure in the entire seismic picture, and almost nobody outside of seismology ever thinks about it. The depth. The rupture happened about 55 kilometers down, roughly 34 miles beneath the surface, inside the subduction system off the southern coast of the Philippines. And depth, in the world of tsunamis, is the difference between a warning that gets stood down and a wall of water that erases a coastline. Think about how a tsunami is actually born, because once you understand the recipe, you understand why today went the way it did. You need that reverse thrust motion, the seafloor suddenly lifting. But you need it to happen close to the surface, in shallow crust. so that the lift of the rock translates directly into a lift of the entire column of water sitting on top of it. Imagine the seabed as the bottom of an unimaginably large bathtub. When a shallow thrust fault snaps right at that bottom, it heaves the seabed upward in an instant, and that heave shoves the whole ocean above it skyward, lifting a mountain of water all at once. That displaced water cannot just sit there piled up. It has to go somewhere. So it collapses outward and races across the ocean as a tsunami, a pulse of energy moving as fast as a jetliner across the open sea. That is the recipe. Shallow, sudden, vertical, right at the seafloor. But at 55 kilometers down, the lift is buried deep beneath layers of crust, and by the time that motion works its way up to the seafloor, it has been spread out, smeared across a wider area and softened. The water column still gets disturbed. The sea still feels it. But the sharp, violent, localized shove that builds a killer wave is muted, blunted by all that intervening rock. Even at a magnitude 7.8, a depth like that takes most of the teeth out of the tsunami. And that is almost exactly what happened, in real time, watched by forecasters around the Pacific. A tsunami advisory went up immediately after the rupture. Then the status was escalated, sharpened into a tsunami threat, and the forecast wave heights were genuinely concerning on paper. 1 to 3 meters along parts of the Philippines, around 1/3 of a meter to a meter for parts of Malaysia. The Gulf of Thailand was expected to see little to nothing. For a few hours that was a live and frightening question, the kind of hours where you watch the coastal buoys and you do not breathe quite normally. Then the reality came in, and the reality was merciful. The largest wave actually observed was on the order of 1.1 feet, about 1/3 of a meter above the normal tide. The threat was declared past. A region that had every reason to brace for water got in the end a shove rather than a flood, and that deep hypocenter, that 55 kilometers, is the single biggest reason why a coastline full of people is not tonight, counting a far worse loss. I want to be careful here though, because even that muted version is not nothing, and I never want to leave you with the impression that a small tsunami is a harmless one. A tsunami is not a wave like the ones you watch roll onto a beach. It is not a curl of water that breaks and politely retreats. It is a wall. It is a sudden rise of the entire sea, a mass of water that pushes inland and then keeps pushing, with the whole weight of the ocean behind it. Even 1.5 feet of that kind of water can take a grown adult off their feet, and once you are off your feet in moving water that fast, you're no longer standing in a flood, you are being carried by it, and people drown in tsunamis in water that standing still would not reach their knees. The danger is the speed and the mass, not the height. So the fact that this one stayed small is genuinely a piece of good fortune, and it hinged on a single number most people will never think about. 55 kilometers. Remember that number. It saved lives today. Let me give you the energy now, because I think the scale of a 7.8 is almost impossible to feel without comparisons, and the comparisons, once you sit with them, are staggering. A magnitude 7.8 releases something on the order of 7.5 million metric tons of TNT equivalent. If that is still just a number to you, a number too big to picture, try these. It is roughly 500 Hiroshima-sized bombs, 500 of them, released in the space of a minute beneath the ocean floor. It is about 1/10 of the energy of the single largest nuclear weapon ever detonated by anyone. The enormous device the Soviet Union tested in the early 1960s, the most powerful explosion humanity has ever deliberately created. It is around 3% of the energy of the Krakatoa eruption of 1883, an eruption so violent that it was heard thousands of miles away and altered the colour of sunsets around the entire globe for years. And to bring it back to earthquakes themselves, to that question of the scale, it is roughly 200 times the energy of a magnitude 6.5. 200 times. That is what that small-looking gap on the scale actually means. Every step up the magnitude ladder is a leap across a chasm, not a step up a stair. There is something almost vertiginous about really sitting with that comparison, the 500 Hiroshima bombs, and I do not offer it for shock value, but because it forces a kind of honesty about the forces involved. We tend to think of human technology as the most powerful thing in our world, our weapons, our machines, our engineering, and then the Earth, in a minute and a half, along a single fault, casually releases the energy of hundreds of our most fearsome weapons, and it does this not as a rare apocalyptic event, but as something that happens somewhere on the planet most years, as routine planetary housekeeping. The ground we treat as the very symbol of permanence and safety is in fact one of the most powerful and least controllable forces we will ever stand near. And this matters for our central question in a specific way, because when you grasp how colossal the energies stored in a fault truly are, you start to understand why scientists are so skeptical that a faint electromagnetic whisper from the sun could be what tips it. The thing being tipped is almost beyond comprehension in scale. The proposed finger on the trigger is, by comparison, impossibly light. That mismatch is at the very centre of the scientific doubt, and we will come back to it, but feel it now, the sheer disproportion between the gentle solar nudge and the monstrous thing it is supposed to move. So why are we, in a strange and uncomfortable way, fortunate that it was only a 7.8? Because the southern Philippines can do far worse than this. This is a place that has produced magnitude 8, even magnitude 8.5, in its recorded history. A magnitude 9 is not off the table in a zone like this over geologic time, and a magnitude 9 is not twice as bad as today. It is dozens of times more energetic. Every increment of magnitude that the Earth held back here is an increment of devastation that did not arrive, an order of magnitude of destruction that stayed locked in the rock. I am not saying that to minimize what happened. Buildings came down, people died, families are grieving tonight. I am saying it to be accurate about where this sits on the spectrum of what that fault is capable of. Because that spectrum is going to matter enormously when we ask the hardest question of the night, the question of whether anything beyond the ordinary grinding of the plates had a hand in the timing. And I have to be honest with you about the human cost, because the honest version is harder than the early version, and you deserve the honest version. The United States Geological Survey runs an impact model, an algorithm that estimates likely casualties and damage from the size and location and depth of an event, and it flagged this earthquake as an orange alert. The model spread the likely fatality count across probability bands, something like a 40% chance that it lands somewhere between 10 and 100 deaths, something like a 35% chance it lands between 100 and 1,000, and even a single-digit % chance, but a real one, that it exceeds 1,000. The estimated economic losses run from the low hundreds of millions of dollars up toward $1 billion, possibly more. And here is the thing that experience teaches with these events, the thing worth saying plainly and without any drama at all. The first numbers are almost always low, not because anyone is hiding anything, and we will come back to that accusation later because it matters, but because in the first hours you simply cannot see into the collapsed buildings, you cannot reach the cut-off towns, you cannot count what has not yet been found. The figure climbs over the following days and the following week as the rubble is cleared and the picture sharpens. We have seen this pattern again and again. A neighbouring region, a magnitude 7.7 not long ago, had initial estimates of a few dozen lost, and the real toll climbed into the hundreds and beyond. So when you see those early casualty counts in the first day, hold them gently and expect them to grow. That is not pessimism. That is just how the grim arithmetic of disaster reveals itself. But a quake this size never arrives as a single event and then goes quiet. It arrives, and then the ground keeps talking, sometimes for weeks. And what the ground said in the hours afterward raised a question that is genuinely unsettling, a question that hangs over every great earthquake in the first hours, the question of whether the worst was already behind the Philippines, or whether it was still ahead of them. Part 3, the aftershocks, and the question of foreshock. The moment a great earthquake ends, a second process begins, and that process can last for weeks or even months. The main rupture has thrown the surrounding crust violently out of balance. Stresses that took centuries to build up have been suddenly rearranged, and the rock answers with aftershocks, a long ragged sequence of smaller quakes as the crust settles into its new arrangement, each one a small adjustment, a creak in a house after a heavy weight has been dropped on the floor. Within the first hours after the 7.8, the southern Philippines was hit by at least 3 separate aftershocks of magnitude 6 or greater. The largest came in initially as a 6.4 and was then upgraded to a 6.5. And to be absolutely clear about what that means, a magnitude 6 aftershock is, on its own, a serious and damaging earthquake. In any other week, a magnitude 6 striking a populated area would be the headline. It is only called small here because of the monster that preceded it and rewrote the scale of what counts as large. Let me make the physical reality of an aftershock vivid for you, because the word itself, aftershock, sounds gentle, like an echo, like a fading afterthought, and that softness is dangerous. When the main rupture tore through the crust, it did not leave behind a clean, settled, stable block of rock. It left behind a shattered, fractured, stressed mess. A region of crust where the old equilibrium has been violently destroyed and a new one has not yet been found. Every aftershock is the rock searching for that new equilibrium, one painful jolt at a time, and in a region with buildings already cracked and weakened by the main shock, an aftershock that would have been survivable on its own can be the blow that finally brings a damaged structure down on the people sheltering inside or near it. This is why the hours and days after a great quake are so genuinely dangerous, why rescuers working in the rubble are in constant peril, why people are warned to stay out of damaged buildings. The main shock writes the headline, but the aftershocks write a great deal of the tragedy, picking off the structures the first blow only wounded. There is a rough and surprisingly reliable rule for how this sequence plays out, and it has a formal name in seismology, but let me just give you the substance of it because the substance is what matters. The largest aftershock of a sequence tends to land about 1 full magnitude below the main shock. For a 7.8, that points toward a largest aftershock somewhere around 6.8. And the frequency follows its own pattern too, a steady mathematical decay. They come fast and thick at first, in the opening hours, then thin out as time passes, the rate dropping off in a predictable way over the days and weeks that follow. So for a 7.8, you would broadly expect to see something like 5 or 6 magnitude 6 events scattered across the whole sequence. The strongest of them may be touching that 6.8 mark, and then a long fading tail of smaller and smaller shocks, 5s and 4s and 3s, trailing off for a long time. As the data came in, the Philippines had already logged several of those 6s, with the 6.5 sitting at the top of the list so far, which means, if the rule holds, there may be more to come, and one of them could be a little stronger than what we have seen yet. It is worth understanding why that 1 magnitude rule holds, because it reveals something about how the energy moves. The main shock is the great release, the moment the largest locked patch of the fault finally gives way. But that release does not perfectly resolve every stress in the region. It leaves smaller locked patches, neighbouring segments that were not part of the main rupture, but were pushed closer to their own breaking points by it. The largest of those secondary patches tends to be roughly 1/10 the size of the patch that broke in the main shock, which translates, on that leaping logarithmic scale, to about 1 magnitude lower. So the rule is not arbitrary. It reflects the rough geometry of how stress is distributed and released across a fault system, a fractal sort of self-similarity where the big break is followed by a smaller break that is followed by smaller ones still, the whole sequence echoing down in size like a struck object ringing in ever fainter tones. Knowing that does not make the aftershocks any less dangerous, but it does mean that forecasters were able, within minutes of the main shock, to give the people of the region a reasonable expectation of what was likely still coming, and that expectation is itself a small act of protection, a way of turning raw terror into something that can at least be prepared for. Now, there is a darker branch to this, and I am going to walk you down it carefully, because it is the branch that frightens people most, and it deserves to be handled with respect rather than either dismissed or sensationalized. Every so often, an earthquake that looks for all the world like a main shock turns out, in retrospect, to have been a foreshock, a warning tremor before something even larger. It happens. It is rare, but it happens, and pretending otherwise would be lying to you. The probability that a 7.8 is itself merely the opening act for something bigger is low, on the order of a few percent at the very most, and there is actually a reassuring signal buried in the data here. The very presence of a robust, decaying aftershock sequence is itself a good sign, because a healthy chain of aftershocks fading over time is the signature of a main event releasing its stored energy, not of a system still winding up for a bigger blow. The Earth, in a sense, is sighing out its tension rather than holding its breath. But a few percent is not zero, and history has its sobering examples, so let me name them honestly. In the year 2023, Turkey was struck by a magnitude 7.8, and then, hours later, by a magnitude 7.5, 2 catastrophic earthquakes nearly back-to-back on the same broken fault system, a double event that multiplied the devastation. Go back far enough into the historical record and you find rarer cases still. Double mega quakes hammering the same region in rapid succession, the ground breaking twice in a span that geology usually measures in centuries. These are the exceptions, the unlucky tale of the distribution, not the rule. The overwhelming likelihood, the 95% and better case, is that the 7.8 was the main event and the 6s are its aftershocks, fading over time as the crust settles. But part of being honest with you means naming the small, real possibility rather than pretending it does not exist, and it means watching the next few days with clear eyes rather than either panic or false comfort. Here is the part of the aftershock story that is not speculation at all, that is as solid as earthquake science gets, and it is genuinely the most important practical takeaway of the entire night. When a fault ruptures, it does not simply discharge its own stress and leave the neighbourhood untouched. It redistributes stress. The rupture unloads the patch of crust that broke, relieving the pressure there, but in doing so it loads up the patches around it, the adjacent faults, the neighbouring segments, pressing on them a little harder than before. This is called stress transfer, and it is well understood, well documented ordinary earthquake physics, not fringe at all. And the southern Philippines does not sit on a single isolated fault. It sits in one of the most complicated tectonic neighbourhoods on the entire planet, a place where multiple subduction zones crowd in against one another. There is the Cotabato Trench, the structure this earthquake appears to have ruptured along the southern margin of the Philippines. There is the Philippine Trench to the east. There is the Manila Trench to the north. And both of those neighbours have themselves been restless lately, swarming with their own activity in recent months. A 7.8 on one of them is exactly the kind of event that nudges the stress balance on the others, adding a little to faults that were already loading. So the grounded, defensible expectation, the one a seismologist would sign their name to, is that this region stays active. More aftershocks, yes, and elevated near-term stress on the trenches next door, which is something worth watching closely in the days ahead. The history of this exact place backs all of that up, and it does something else too, something important for the question we're circling. It tells us this earthquake, terrible as it is locally, is not an alien event, not a freak, not an anomaly that demands an exotic explanation. This is, in the long view, a completely normal place for this to happen. The Cotabato Trench has produced very large earthquakes before, including an event near magnitude 8.3 back in 1918, more than a century ago, larger than what struck today. Within 300 kilometres of where this struck, there have been on the order of 35 earthquakes of magnitude 7 or greater across the historical record. 35. The southern Philippines produces a magnitude 7 in most years, year after year, as routinely as the seasons. And in a detail that reads very differently in hindsight than it did at the time, back in January of this year, 2026, an earthquake swarm rattled this very stretch of the Cotabato Trench, with magnitudes ranging from small tremors up to around 5.2, serious enough to force the closure of schools and government offices in the region. At the time it was unsettling but not alarming. Now with hindsight it looks like long-range foreshock activity along the same structure that just failed, the fault clearing its throat months before it finally spoke. The plates here are converging at around 7.3 centimetres a year, one of the faster convergence rates anywhere on Earth, which is precisely why this corner of the world is so relentlessly, exhaustingly productive. The crust here is always being crushed. The stress is always building. The only question is ever when and how big. It is worth pausing on what that convergence rate actually means in human terms, because 7.3 centimetres a year sounds almost trivial, slower than your fingernails grow, slower than the hair on your head. But geology does not work on human time. Run that rate forward across a single human lifetime, and the plates have shoved past each other by several metres. Run it across the century since that great 1818 earthquake, and you have many metres of accumulated motion that the locked fault has been quietly storing as strain, like a spring being wound tighter and tighter and tighter, year after silent year, with nobody able to feel it happening. And then, in 60 to 90 seconds, the spring releases everything it has been hoarding for a century. That is what a great earthquake is. It is a century of imperceptible, patient loading, discharged in a minute and a half of catastrophe. The slowness of the loading and the suddenness of the release is the whole brutal arithmetic of why these zones are so deadly. The danger builds invisibly, on a timescale no human can perceive, and arrives all at once on a timescale no human can outrun. So that is the geology, and I want you to notice something about everything I have just told you, because it is going to make the next act of this story almost unbearably interesting. Every word of it is textbook. The mechanism is textbook. The depth muting the tsunami is textbook. The aftershock decay is textbook. The stress transfer is textbook. The regional base rate is textbook. There is nothing in the earthquake itself, taken purely on its own terms, that a seismologist would call mysterious or unexplained. A well-known fault in a well-known collision zone failed in a well-known way, roughly on schedule with its own long and violent history. If you handed the seismic data to an expert with the date stripped off, they would shrug and say, yes, the Cotabato Trench did what the Cotabato Trench does. And that is exactly what makes the next part of this story so hard to look away from. Because this textbook earthquake, this completely explicable rupture that needs no exotic cause at all, arrived on the single day when the sun was throwing everything it had at us. The most ordinary kind of great earthquake, on the most extraordinary kind of solar day. So now we have to turn away from the ground and look up. Part 4. What the sun had been doing. To understand why the timing of this earthquake made so many people stop and stare, why it set off a quiet alarm in the back of so many minds, you have to rewind a few days and look at what our star had been doing in the lead-up. Because the sun did not have a quiet week. The sun had one of the more eventful weeks it has had in a good while, and the remarkable thing is that almost all of it was coming from essentially one troubled neighbourhood on its surface, a single active region complex working itself into a frenzy. It began with the flares. On the 3rd of June, that one active region complex, one of those dark, magnetically twisted clusters of sunspots, where the sun's magnetic field gets knotted and strained, lit off a barrage. First, a magnitude 9.3 flare and a magnitude 7.7 flare within about a 10-hour window, both of them powerful M-class events, the second strongest category of flare we have. And then, later that same day, it escalated again, all the way into X-class, the most powerful category there is, with a flare around X 1.0. Let me put that in perspective, because going from a quiet sun to an M9 and M7 and an X flare all inside a single day is genuinely a lot. The flare classes are themselves a leaping scale, like the earthquake magnitudes, where each letter is roughly 10 times the energy of the one below it. C-class is minor, M-class is moderate to strong, the kind that can disrupt radio. X-class is the top, the flares capable of the most serious effects. For one region to fire an M9 and M7 and an X all in one day is the solar equivalent of a fault zone that has decided it is not finished with you yet. It is a region in revolt. Now, what does a flare actually do, and what does it not do? A flare is a flash of radiation, light and the X-rays and ultraviolet, that crosses the gap to Earth at the speed of light. It arrives in about 8 minutes, the same 8 minutes it takes ordinary sunlight to reach us, and when a strong one hits, it can disturb the upper atmosphere and degrade or black out radio communications on the daylit side of the planet within minutes. That is real, and it matters for aviation and emergency communications. But, and this is crucial for our story, flares are not the part that reaches down and could conceivably touch the ground. The radiation flash disturbs the air high above us, and then it is gone. For something with the potential to interact with the solid Earth, you need the heavier ammunition, the part of the sun's arsenal that travels slower but hits harder. That came on the 6th of June. The sun launched a coronal mass ejection, and I want you to actually picture what that is, because the words make it sound abstract and clinical, and it is anything but. A coronal mass ejection is a cloud of magnetized plasma, an enormous blob of electrically charged particles wrapped up in its own magnetic field, blasted bodily off the surface of the sun and hurled out into space. We are not talking about a beam of light. We are talking about matter, about something on the order of 1 billion tons of solar material flung outward across the 93 million mile gap toward the planets, like a cannonball the size of a world. This particular cloud was associated with a filament erupting off the sun's surface, a great arc of plasma tearing loose, and we got an early read on its speed from something called a Type 2 radio sweep, which is a kind of radio signature that a shock wave produces as it tears outward through the sun's atmosphere, a sonic boom in plasma that we can hear in radio. That signature implied the cloud was moving at something like 838 kilometers per second. Let that land. 838 kilometers every second. Fast. And aimed, at least in part, our way. And I want you to hold on to that image of 1 billion tons of solar material crossing the gap, because it does something useful to our intuition. We tend to imagine space as empty, as a perfect vacuum separating the sun from the Earth, a clean void. But it's not empty, not really. The space between us and the sun is filled with the solar wind, a constant outward breath of charged particles. And through that medium the sun hurls these enormous clouds, and our planet sits inside all of it, bathed in it, swimming in the sun's atmosphere in a very real sense. The Earth is not a separate body politely orbiting at a safe distance. It is embedded in the sun's extended environment, connected to it by magnetic field lines and particle streams, close enough to feel every cough and every storm. When you really internalize that, the question of whether the sun can affect the Earth stops sounding exotic because the sun affects the Earth constantly every day in a dozen documented ways. The only question that is genuinely open is whether that constant connection extends in some unproven way all the way down into the solid rock and the faults within it. Now layer in the geomagnetic storms, because this is where the timing gets tight enough to make your skin prickle, where the calendar starts to feel almost deliberate even though we know it is not. A geomagnetic storm is what happens when one of these clouds, or a stream of fast solar wind, slams into the Earth's magnetic field and shakes it, sets the whole protective magnetic bubble around our planet trembling and reverberating. We rate these storms on a scale that runs from G1 for minor, up through G2 moderate, G3 strong, G4 severe, all the way to G5 for extreme. 2 days before the earthquake, on the 5th of June, the Earth had already taken a G2, a moderate geomagnetic storm with the planetary activity index, the number we use to measure the disturbance, peaking around 6.3. The planet had, in a very real sense, just been rung like a bell by the sun, its magnetic field set vibrating. And then, looking ahead to the 8th of June, the very day this earthquake struck in local time, the official forecasters at the Space Weather Prediction Center issued a formal watch, not for a minor storm, for a G3, a strong geomagnetic storm, driven by the arrival of that 6th of June cloud, with the activity index forecast to peak around 6 2/3 in the afternoon hours, universal time. So the earthquake did not just happen near some vague, hand-wavy period of solar activity. It happened sandwiched precisely between two named geomagnetic storms, a moderate one 2 days behind it, and a strong one forecast for the same day. And there were the particles, which are going to matter a great deal when we get to the heart of the question, so pay attention to these. In the days around the cloud's arrival, the energetic particle environment around Earth climbed steeply. The flux of higher energy electrons out at the altitude of our geostationary satellites rose to high levels, peaking around 2,874 particle flux units, well past the threshold that triggers an ongoing alert, and high enough to be a genuine concern for the satellites flying through it, which can build up dangerous static charge in that environment. The proton flux, the heavier charged particles, stayed below the level we would formally call a radiation storm, but it too was clearly enhanced, lifted well above its quiet baseline, and the lower energy particle counts were climbing as the shock front from the cloud arrived. In one reading drawn from the live coverage of the event, a relevant proton measurement rose from a quiet baseline of around 15 or 20 hundredths up to roughly 1, an increase of several 100%, even as it stayed below the storm threshold. The space around our planet, in plain terms, was energized, charged, lit up with incoming particles from the sun. It is worth understanding just how routinely these storms touch our technological lives, because it grounds the whole question in something real rather than abstract. The grandest, most famous example is from more than a century and a half ago, an event so powerful that telegraph systems sparked and in some cases set their own paper on fire, an event that, if it struck our wired and satellite-dependent world today, could do staggering damage to power grids and electronics across whole continents. We have had smaller modern reminders too. A storm decades ago that collapsed an entire regional power grid in well under 2 minutes, plunging millions into darkness in the depth of winter, and more recent storms that have degraded satellite navigation, disrupted aviation routes over the poles, and even pulled newly launched satellites out of orbit before their operators could react. So when I tell you a strong geomagnetic storm drives currents through the ground and through our infrastructure, this is not a theoretical worry dredged up for drama. It is a documented, ongoing vulnerability that the engineers who run our grids think about constantly. The sun reaching out and touching our technology is established fact. The only open question, the one this whole video turns on, is whether it can also, in some far subtler way, reach out and touch the ground itself. So what does a geomagnetic storm actually do to the Earth? In plain language, stripped of jargon. When that cloud hits and shakes our magnetic field, it drives electrical currents. Currents high in the atmosphere, in the layer we call the ionosphere, which is what lights up the aurora, the northern and southern lights, and which can scramble radio signals and degrade the navigation signals coming down from satellites. And, crucially for the question we're about to ask, it drives currents in the ground itself. This is not speculation, this is established physics. A changing magnetic field induces electric currents in anything that conducts electricity beneath it, and that includes the crust, and it includes the long conductors we humans have strung across the surface, the power lines and the pipelines, which is exactly why a strong enough storm is a genuine threat to electrical grids. So during a strong geomagnetic storm, the Earth is not a passive, inert rock sitting quietly in space. It is a body with currents running through its skin and its upper air, jostled and disturbed by the arrival of solar material. Keep that fact close, because it is the seed of the whole speculation we are building toward. And here is the thing I most want you to take from this part of the story. Every one of those numbers I just gave you, the M9, the M7, the X-flare, the billion-ton cloud, the 838 kilometers a second, the G2 behind and the G3 ahead, the electron flux of nearly 2,900, the rising proton counts, the currents driven into the ground, every single one of them only matters to this particular story because of when it all happened. On its own, in isolation, this would have just been an active solar week. The kind we cover all the time on this channel, the kind that paints auroras a little farther south than usual and makes the satellite operators nervous and gives the aurora chasers a good night. That was, in fact, the story we were all telling just the day before. The talk was all about the inbound cloud and the strong storm it was forecast to bring, the auroras it might push toward the horizon, the question of whether your lights would stay on. A solar storm, arriving on schedule. That was the headline. And then, alongside that forecast storm, right on the day it was due to peak, something else arrived. On the far face of the planet, the ground tore open, the strongest earthquake of the year. So now we have the two halves laid side by side on the table, and we cannot unsee how neatly they fit against each other. A charged-up sun storms front and back, particles streaming in across 93 million miles, and a broken seafloor, the strongest quake of the year, in the same 48 hours. The obvious question, the one your mind has almost certainly been forming since the first minute of this video, is whether one had anything to do with the other. It is time to take that question seriously. Not to answer it with a confident, thrilling yes, which would be dishonest and would betray everything this channel stands for, and not to wave it away with a reflexive, dismissive no, which would be lazy and incurious and would miss something genuinely worth examining. We're going to actually look at it from both sides, with our eyes open. Part 5. The idea that the sun can shake the earth. So let us put the question on the table in its strongest, fairest form, and then let us test it from both sides, because this is the part of the night where it would be very easy to lose your head, to get swept up in the pattern, and I'm not going to do that to you. I am going to give the idea its best case, the strongest version a thoughtful proponent would offer, and then I am going to give the other side exactly the same weight, and we are going to see where honest reasoning leaves us. The idea is this: that intense space weather, the storms and particle floods coming off the sun, can influence the timing of large earthquakes here on Earth. Not cause them out of nothing. I want to be precise about the claim. Not summon an earthquake where there was no stored stress. Influence the timing. Nudge a fault that was already loaded and already going to fail eventually into failing now, today, rather than next month or next year. And there is a specific testable shape to this claim, which is exactly what makes it interesting rather than just a vague feeling that everything is connected. The researchers who report a connection say it is offset in time, and the offset is the key detail. It is not that the particles hit and the ground shakes in the same instant. It is that the particle enhancement arrives first. The Earth is, in their framing, charged up by the incoming flux of solar particles, and then roughly 24 hours later, about a day later, the statistical likelihood of a large earthquake appears to rise. A delay, a lag of about a day between the sun's blow and the Earth's apparent answer. And I want you to notice, because we genuinely cannot unnotice it now that we have laid out the data, that this is exactly the pattern today's sequence shows. The particle flux climbed in the day before the quake. The quake came roughly a day later. If you were a believer in this idea, if you'd built your whole framework around that one-day offset, today is the textbook case you would point to, the cleanest example you could have hoped for. What would the actual physical mechanism even be, though? Because correlation without a mechanism is just a suggestive coincidence dressed up in a lab coat, and to their credit, the proponents do offer mechanisms, real physical proposals you can examine. The leading idea is electromagnetic. A strong geomagnetic storm, as we just discussed in detail, drives currents in the ground, those geomagnetically induced currents, and it perturbs the planet's global electric circuit, the natural background flow of electrical energy, through the atmosphere and the surface of the Earth. The argument goes like this. A fault which is already loaded to the absolute brink of failure, already strained to within a hair of slipping after centuries of accumulating stress, might be tipped over that final edge by even a tiny additional push. And the electromagnetic disturbance of a major storm, the argument says, could be that tiny push, that last small straw. There is a newer line of work proposing something called capacitive coupling, the idea that the charged ionosphere overhead and the conductive ground below behave a little like the two plates of a capacitor, an electrical component that stores charge across a gap, and that storm time changes in that vast natural capacitor could translate into subtle stress changes at depth. The unifying theme running through all of these proposals is the same, and it is genuinely the most compelling part of the case. A critical fault, one right at its breaking point, needs almost nothing to release. The sun, during a strong storm, supplies a little something extra to the system. Maybe, the argument goes, just maybe, that little something is occasionally enough to be the trigger that decides the exact moment. And on a day like today, you can feel the pull of it, the gravitational tug of the pattern on your mind. The offset lined up. The particle enhancement preceded the quake by about the very interval the theory predicts. The event was bracketed by two geomagnetic storms, one on each side, and it was capped, not by some middling forgettable tremor, but by the single largest earthquake of the entire year. If you wanted to design a poster child for the solar earthquake hypothesis, if you sat down to construct the perfect supporting case, the universe could hardly have arranged a cleaner one than what actually unfolded over these 48 hours. I am not going to pretend that is not striking. It is striking. It would be dishonest to pretend otherwise. Now I am going to turn around and give you the other half, and I am going to give it the very same weight, because that balance is the only way to think honestly about something like this. And it is the thing that separates careful curiosity from wishful thinking. The scientific consensus, the position held by the large majority of seismologists and space physicists who study these systems for a living, is firmly skeptical of this idea. And their skepticism is not stubbornness, not closed-mindedness, not the establishment refusing to consider something new. It rests on solid ground, and you deserve to understand that ground as well as you understand the case for the link. First, there is no established, demonstrated physical mechanism by which the sun reliably triggers earthquakes. The proposed pathways I just described to you are conceivable. They are not absurd, but here is the problem they have never overcome. The energies involved in even a strong geomagnetic storm are minuscule compared to the colossal, almost unimaginable stresses stored up in a major fault zone, stresses built over centuries by the relentless motion of tectonic plates. Bridging that enormous gap, explaining convincingly how a faint electromagnetic perturbation at the surface overcomes the difference and actually tips a fault that is kilometers deep, has not been done. The proposed nudge is real but tiny, and the thing it is supposed to nudge is gigantic, and nobody has shown persuasively that the tiny thing can move the gigantic thing. And then there is the deepest problem of all, the one you absolutely have to internalize if you want to think clearly about any claim like this, about any claim of the form. These two dramatic things happened near each other, so they must be connected. It is the problem of coincidence, and it is not a hand wave, it is not me being a killjoy, it is mathematics, and once you see it, you cannot unsee it. The Earth produces large earthquakes constantly. Magnitude 7 and above happens many times every single year, all around the planet, along every major fault and subduction zone. The Sun, especially in an active stretch of its 11-year cycle, like the one we are currently living through, storms constantly, firing flares and launching clouds and buffeting us with fast wind. Now when you have two phenomena that both happen frequently, Some of their occurrences will line up in time purely by chance. They have to. It is unavoidable, it is guaranteed, it is just how probability works when you have many events on both sides of the ledger. So if you go looking, after the fact, for earthquakes that happen to occur near solar storms, you will always find some. Not because one caused the other, but because both are common and the calendar only has so many days in it. Some overlaps are mathematically certain, even in a universe where the sun and the earthquakes have absolutely nothing to do with each other. This is precisely why the careful studies, the ones that look at hundreds or thousands of events with proper statistical controls, matter so much more than any single dramatic case, no matter how clean that single case looks, and the careful studies are genuinely, honestly mixed. Some have reported statistical correlations at various levels of significance, and those are worth taking seriously and not dismissing. But others, applying equally rigorous or more rigorous methods, have found no robust relationship at all once you account properly for chance. And here is a detail that proponents tend not to dwell on. At least one high-profile recent great earthquake, a major event that everyone watched closely, produced a clean negative result. It occurred at a time that simply did not fit the solar trigger pattern, when the sun was quiet, a data point that argues directly against the hypothesis. A real theory has to account for the cases that do not fit, not just the ones that do, and the solar trigger idea has cases that do not fit. There is also a subtle trap in how this kind of data gets chosen, a thing scientists call selection effect, and it is worth understanding because it is how a lot of seductive false patterns get manufactured without anyone intending to deceive. If you decide, after you already know an earthquake happened, which solar measurement to look at, the wind speed, or the particle density, or the proton flux, or the magnetic field angle, or any of a dozen other variables, and you are free to pick whichever one happens to correlate with your earthquake after the fact, then you can almost always find some relationship in some variable. With enough variables to choose from, chance alone guarantees that one of them will look meaningful. That is not discovery, that is fishing. And distinguishing a genuine signal from that kind of after-the-fact pattern matching, where you draw the target around the arrow after you have already shot it, is exactly what separates the convincing studies from the unconvincing ones. And it is hard, painstaking work that a dramatic single coincidence completely bypasses. So here is the honest verdict, stated as plainly as I can state it, and I want you to hold all of it at once, all the pieces together, because the holding of it is the entire point of this video, the whole reason we are here. The correlation is intriguing. The proposed mechanisms are physically conceivable but unproven. The mainstream consensus is skeptical, and that skepticism is well founded on real problems, not prejudice. And one beautifully aligned event, like the one we are living through today, proves absolutely nothing on its own, because a single striking coincidence is exactly what the chance hypothesis predicts you will see from time to time. Only a pattern across hundreds of events, analysed carefully without cherry-picking, without fishing, without drawing the target around the arrow, could ever settle this question, and that pattern has not been convincingly demonstrated in either direction. This is why the timing today is so hard to look away from, and so dangerous to overread, in the very same breath, at the very same moment. Both things are true at once. The timing is striking, and coincidence is the null hypothesis, and it has not been beaten. I will tell you where I personally land, because you deserve to know, and because I think it is the only intellectually defensible place to stand. We do not know. The burden of proof is on the claim, the way it always is for an extraordinary claim, and the claim has not yet met that burden. The most that a clear-thinking, honest person can say about today is that it is a fascinating, almost too perfect data point in a question that remains genuinely, legitimately open. Not closed in favour of the sun, not closed against it, open. And there is something both humbling and a little thrilling about standing in front of a genuine open question and resisting the urge to slam it shut in either direction, just to relieve the discomfort of not knowing. And if the solar earthquake link is one pattern that the human mind desperately wants to believe in, one shape it wants to impose on the chaos, there is a second pattern hiding in today's data that is, in some ways, even stranger and even more tempting. And to find it, we have to travel to the exact opposite side of the world. Part 6. The Other Side of the World. Take the point where this earthquake struck, the southern Philippines, and drill an imaginary line straight down through the molten centre of the Earth and out the other side. Where does it come out? Near the middle of Brazil. That point, the exact opposite spot on the globe from any given location, is called the antipode. And there is a curious thing about today's data once you know to look for it. A thing that the pattern-seeking part of your brain is going to seize on the moment I tell you. The previous largest significant earthquake before this 7.8, the one that had held the unwelcome title until the Philippines took it, was a magnitude 6.9 that struck near the Chile and Peru Trench, over in South America. And that location sits remarkably close to the antipode of the Philippines quake. Two of the largest recent earthquakes on the entire planet, on nearly opposite faces of it, as if the Earth had been struck on one cheek and then, sometime later, on the other. Is that meaningful? Or is it the very same trap we just spent the last part of this video learning to recognize the same coincidence machine wearing a different costume? Let me give you the real physics first, because the real physics here is genuinely strange and genuinely true, and worth knowing for its own sake. And then I will give you the part where we have to put our skeptic's hat firmly back on. When a great earthquake happens, the whole planet rings. I mean that almost literally, and it is one of the most beautiful facts in all of geophysics. The Earth has natural resonant frequencies, deep tones at which it likes to vibrate, the same way a bell does, the same way a wine glass does when you run a wet finger around its rim. And a sufficiently large earthquake sets the entire globe vibrating in those deep, slow tones, oscillations so low and so vast that they continue for hours, sometimes even days after the shaking at the surface has long stopped. This is not speculation. We measure it routinely with sensitive instruments after every great quake. The Earth, for a while, after a magnitude 7.8, is a struck bell, humming to itself in frequencies far too low for any human ear, the whole planet quietly resonating from the blow. And the seismic waves that race outward from a rupture do not simply fade away evenly in all directions like ripples dying on a pond. They travel through the body of the planet and they bend. They refract as they pass through layers of different density and composition. They curve around the dense metallic core, and on the far side of the world they can actually reconverge, focusing back together near the antipode the way light bends and focuses through a lens. When seismic waves come back into focus like that on the far side, they can constructively interfere, their energy adding together, and in some cases this produces a measurable disturbance at the antipode. Even apparent ghost arrivals on distant seismographs, phantom signals of energy that wrapped all the way around the planet and amplified itself at the focal point on the other side. So the idea that a great earthquake reaches across the entire planet and is felt, in some measurable way, at its antipode is not crazy at all. The ringing is real. The wave focusing is real. Far-field stress changes, tiny adjustments to the stress balance on faults very far from the original rupture, are real and are genuinely studied by serious scientists. So far, everything I have told you in this part is grounded, established mainstream Earth science. Here is where the caution comes rushing back, though, and where we have to be just as disciplined as we were with the Sun. There is a very large difference between two statements that sound similar, but are worlds apart. One statement is, the planet rings, and seismic energy focuses at the antipode. That is established and true. The other statement is, a great earthquake on one side of the world triggers another great earthquake on the other side. That is far, far less certain, and it is exactly the kind of claim that the human brain is exquisitely, almost dangerously tuned to believe. We are pattern-finding animals, descended from ancestors who survived by seeing the lurking predator in the rustling grass, and the cost of seeing a predator that was not there was low, while the cost of missing a real one was death. So evolution tuned us to find patterns everywhere, to err massively on the side of seeing connection, which is wonderful for survival and treacherous for science. It means we also see faces in clouds, and shapes in the stars, and meaning in coincidences. When you have a planet that is producing large earthquakes all the time, all around the Ring of Fire and along every major fault on Earth, you will absolutely be able to find pairs of big quakes that sit near each other's antipodes, in exactly the same way, and for exactly the same reason, that you can find earthquakes that sit near solar storms. The existence of the pair does not prove the connection. It is necessary for the connection, but it is nowhere near sufficient. And so notice what has just happened, because it is the deep structure of this entire night coming into view. We now have two separate patterns from a single day, and they have the identical shape. The sun and the quake, separated in time by about a day. The Philippines and Chile, separated in space by nearly the whole diameter of the planet. Both look meaningful. Both might contain a genuine kernel of something real. Because the underlying physics in each case is not absurd, there are real mechanisms on the table. And both sit on top of a planet so active, with so many earthquakes happening and so many solar storms arriving, that some apparent connections are statistically guaranteed to appear whether or not anything is actually linking them. That is the genuine intellectual challenge of a day like today, and I want to name it as clearly as I can. The challenge is not to find patterns. The patterns are easy. They leap out at you, they practically grab you by the collar. The challenge, the hard and unglamorous work, is to figure out which of the patterns are real and which are the mind's own machinery running ahead of the evidence. I want to dwell for a moment on why the antipodal idea is so seductive, because understanding the seduction is how you inoculate yourself against it, and the inoculation is the real skill worth carrying out of this video. The antipode is a clean, satisfying, symmetrical idea. The Earth is a sphere, and a sphere has a beautiful geometry, and the notion that a blow on one side echoes out and strikes the exact opposite point has the elegant, almost mythological feel of cause and effect made visible, of the planet as a single responsive body. It feels right. It feels like the kind of thing that should be true. And that feeling, that sense of rightness, of elegant symmetry, is precisely the warning sign, because the universe is under no obligation to be elegant or symmetrical or satisfying to the human aesthetic sense. Reality is frequently messy, asymmetric, and indifferent to our love of clean patterns. When an idea feels too beautiful, too tidy, too satisfying, that is exactly the moment to tighten your skepticism rather than relax it. Because beauty is one of the most effective lures the mind uses to talk itself into believing things that are not so. The antipodal pairing is beautiful. That is a reason to examine it harder, not a reason to believe it. And the Earth gave us even more to weave into the story today, if we are inclined to weave, and I want to show you the threads precisely so you can feel the pull and then feel the discipline of resisting it. Around the time of the earthquake, the Pacific Ring of Fire was lit up with volcanic activity. In the Philippines themselves, Mayon and Canlaon were in active eruption. Across Indonesia, a whole roster of volcanoes was venting and erupting, plumes rising in multiple places. Off Papua New Guinea, the largest ongoing eruption on the entire planet this year, a submarine eruption along a feature being called the Titan Ridge was still pumping away beneath the waves. To someone in the grip of the everything is connected feeling, that roster is the clincher, the final brick in the wall. The sun storms, the ground breaks, the volcanoes roar all at once, all in the same window. How could that be coincidence? But here is the grounded version, and I genuinely find it almost more interesting than the cosmic one, because it is true. The Ring of Fire is a single, interconnected system. It is the same continuous ribbon of subduction zones and faults and volcanic arcs wrapped all the way around the Pacific Ocean, and all of it is under continuous, relentless stress from the same underlying plate motions. So clustered earthquake and volcanic activity around that ring is not a sign of cosmic alignment or a message from the heavens. It is the entirely expected behavior of one enormous, stressed interlocking machine, parts of which are essentially always active because the whole thing is always being driven. Could the 7.8 have nudged a nearby volcano that was already primed and ready, accelerating its degassing or its eruption through the passage of its pressure waves shaking the magma? Yes, possibly. A large quake can perturb a volcanic system that is already on the very edge of erupting. But it does not ignite a quiet, dormant volcano out of nothing, and the activity around the ring was, for the most part, already well underway before the ground broke today. The volcanoes were not woken by the quake. They were already awake, and here is a subtle point that I think is the key to the whole thing, the lesson that outlasts this particular earthquake and this particular storm. The danger is not in noticing patterns. Noticing patterns is good. It is the beginning of all science. It is how every real discovery starts. Someone notices that two things seem to go together, and they get curious. The danger is in stopping there, in mistaking the noticing for the proving, in letting the thrill of the apparent connection substitute for the hard, often disappointing work of testing whether the connection is real. The believer and the scientist both start in the same place, with a noticed pattern and a quickened pulse. The difference is what they do next. The believer says, look, a pattern, it must mean something, and stops. The scientist says, look, a pattern, I wonder if it means something, and then spends years trying to prove themselves wrong, because that is the only way to find out if they are right. Tonight, with the sun and the quake, with the Philippines and Chile, we are all standing at that fork. We have noticed the patterns, the pulse is quickened. The only question that matters now is which path we take from here, which brings us finally to the real heart of this entire night, the thing underneath all the other things. The battleground is not the sky, and it is not the sea floor, and it is not even the volcanoes. The battleground is the line, the impossibly fine and shifting line, between a pattern that is real and a pattern that is a trick of the mind. That line is the hardest territory in all of science to navigate, the place where careers are made and reputations are lost, and it is exactly the territory where, when the official explanations start to feel cold and unsatisfying, something darker than fringe science moves in to fill the gap, the conspiracies. Part 7. Why the numbers changed and why that scares people. Let us go back to something I flagged at the very beginning and promised we would return to. The magnitude. Remember how the first readings came in around 8.1, 8.2, that frightening flirtation with megaquake territory, and then the official figure settled down to 7.8. To a scientist, that revision is the system working exactly as it is supposed to, the normal refinement of a measurement as more data arrives. But to a very large number of people watching online, in real time, that same revision is something else entirely. To them, it looks like the truth was quietly downgraded. It looks like someone somewhere in some agency made a deliberate decision to make a catastrophe sound smaller than it actually was. And this reaction is worth taking seriously, not because the cover-up reading is correct, it is not, but because understanding why people instinctively reach for it tells you something genuinely important about trust, and about how the very same open question we have been carefully wrestling with all night can curdle into something corrosive if it is handled carelessly. So let me explain, plainly and completely, why the number changed. When a great earthquake happens, the first magnitude estimate is generated automatically, by computer, from the first scraps of data arriving from the nearest seismometers within minutes of the rupture. It has to be that fast, because tsunami warnings depend on speed, because every minute matters when there might be a wave racing toward a coastline, and fast inevitably means incomplete. Those earliest estimates are genuinely just first glimpses, snapshots taken in poor light, and they are noisy. They scatter. They are computed before the full seismic waves from the event have even finished crossing the planet. As the minutes pass and those waves reach more and more stations all around the world, and as the full waveform of the event, the entire detailed shape of how the fault ruptured, gets properly analysed by both computers and human experts, the estimate is refined, sharpened, corrected. And here is the part that defeats the cover-up reading. It refines in both directions. Sometimes the final number ends up higher than the preliminary one. Sometimes, as happened here, it ends up lower. The slide from 8.2 to 7.8 is not a downgrade in the sense of someone deciding to soften the blow for the public. It is simply the difference between a hurried snapshot taken in the dark and a careful photograph developed in full light. The revision is a feature of how the science works, a sign of the system doing its job, not a crack in it, and certainly not a conspiracy. But I understand the instinct behind the distrust, and I do not want to mock it, because mockery never changed a single mind, and because the instinct comes from somewhere real, and it extends well past earthquake magnitudes into a much broader suspicion. There is a wider version of it that says they would not tell us if something truly big were coming. Whether it is a catastrophic earthquake or an asteroid on a collision course with the planet, the suspicion is that the authorities would simply keep it quiet to prevent mass panic, that we would be left in the dark for our own supposed good. And I want to answer that one honestly and directly, because it deserves an honest answer rather than either blind reassurance or contemptuous dismissal. Here is the strongest reason the cover-up scenario does not hold together for events like these, and it is not an appeal to trust the authorities, it is the opposite. The data is not locked in a vault controlled by a handful of officials. The community of people watching the planet and the sky is enormous, and it is decentralized, and a great deal of it is not under anyone's control at all. There are raw seismometer feeds you can pull up yourself right now, from networks all over the world. There are tsunami buoys reporting their measurements in near real time, and you can watch the water level on them yourself. There are solar telescopes streaming continuous live images of the sun for anyone to see. There are thousands of amateur astronomers scattered across every continent, with the equipment to independently track a large asteroid, and absolutely no incentive or instruction to stay quiet about what they find. For a genuinely detectable major event to be successfully suppressed, you would have to silence not one agency, but a sprawling, global, overlapping, fiercely independent web of observers, many of whom would love nothing more than to be the one who broke the news. And that is very close to impossible. The openness of the data is itself the antidote to the cover-up. The very fact that you can go and check yourself tonight is the reason you do not have to take any of it on faith. And this lets me draw the line that this channel always tries to draw, the line that I think matters more than any single fact in this entire video. There is fringe science, and there is conspiracy, and they are not the same thing, and collapsing them together is one of the easiest and most damaging mistakes a curious person can make. The contested idea that space weather might influence the timing of the earthquakes, the thing we spent the heart of this video carefully examining from both sides, is fringe science. It is a real, if marginal and unproven research question, with actual peer-reviewed studies on both sides of it, conceivable physical mechanisms on the table, and a genuine scientific debate ongoing. It deserves an open mind held in tension with a firm demand for evidence. That is how you treat fringe science. But the idea that the authorities are deliberately suppressing earthquake magnitudes, or secretly hiding incoming catastrophes from the public, is conspiracy. And it gets a different treatment entirely. It gets, here is what people are claiming, and here is what the evidence actually shows. And the evidence shows the claim does not survive contact with how the data actually flows in the real world. One is a question worth investigating with genuine curiosity. The other is a story that falls apart the moment you understand the decentralized, open nature of the observations. And there is a third thing circulating during events like this, and I am going to name it and then set it firmly aside, because chasing it would throw away everything the rest of this video has worked so hard to earn, and I will not do that. That is the idea that you can fold the earthquake, the volcanoes, the solar storm, and the positions of the planets in the night sky all together into a single grand cosmic omen. That a particular alignment of the planets in the sky is somehow part of the trigger, part of the cause. I have to be very clear and very firm about this. There is no credible physical mechanism by which the configuration of Venus, or Jupiter, or any other planet in our sky reaches down and influences a fault in the Philippines. The gravitational tugs involved are real, but vanishingly, almost comically tiny, utterly swamped by far larger gravitational effects we already fully understand and account for, the daily tides from the moon and the sun being thousands upon thousands of times stronger. When you start linking earthquakes to planetary alignments, you have crossed a bright line, out of the territory of fringe science and into the territory of astrology, and I'm not going to take you there, because the moment you do that, the moment you let the cosmic omen thinking in, you forfeit the right to be taken seriously about any of the real and genuinely open questions we have been so carefully, so honestly examining all night. The solar earthquake question is hard and worth our time precisely because it is not that. It is a real question, grounded in measurable particle fluxes and conceivable physical mechanisms and actual statistical studies. Keeping it cleanly separated from the cosmic omen material is not pedantry. It is how we protect the real question from being dragged down and discredited by the nonsense that likes to cling to it. There is one more thing worth saying about the cover-up instinct, because I think it comes from a place that deserves compassion rather than contempt. When something enormous and frightening happens, something that reminds you in an instant how fragile your safety actually is, the mind reaches for control wherever it can find it. And believing that someone, somewhere, knows more than they are telling, that the numbers are being managed, that there is a hidden hand behind the scenes, is, perversely, a kind of comfort. It is more bearable to believe in a sinister but competent authority hiding the truth than to accept the harder reality, which is that nobody is fully in control, that the planet does what it does on its own schedule, and that the experts watching it are, like the rest of us, often surprised, often uncertain, often learning in real time. The conspiracy, in a strange way, restores order to a universe that has just demonstrated its disorder. I understand that pull, but the honest path, the harder and ultimately braver path, is to sit with the genuine uncertainty rather than to paper over it with a story of secret control. The truth is less comforting than the conspiracy and far more interesting, because the truth is that we are all, experts included, standing on a planet we only partly understand, watching it together, figuring it out as we go. And notice, finally, why we can even ask the real question honestly in the first place. It is because the data is open. We can look at the proton flux ourselves. We can pull up the storm forecasts, the seismometer traces, the tsunami buoy readings, the solar images, all of it, with our own eyes tonight. The very openness that defeats the cover-up narrative is the same openness that lets us examine the solar timing seriously, rather than simply choosing to believe or disbelieve it on faith. We do not have to choose between gullibility and paranoia, between swallowing every cosmic story whole and dismissing every genuine mystery as noise. We have a third option, the only good one, which is to look carefully, patiently, with both eyes open and both feet on the ground. So where does all of that leave us? Standing here at the end of the night, staring at a timing that refuses to resolve itself on a planet that refuses to stop moving beneath our feet. Part 8. A Coupled Planet. Let me pull the lens all the way back now, because after a day this full, this crowded with dramatic individual pieces, it is easy to get lost in the details and lose the shape of the whole, and the big picture is actually steadier and, in its own quiet way, more profound than any single dramatic detail we have examined. Here is the picture, the real one. We live on a coupled planet, not a collection of separate, sealed-off systems that happen to share an address in space, but a single, deeply interconnected machine whose parts genuinely do talk to each other in ways both obvious and subtle. The tectonic plates are under continuous stress, grinding and locking and releasing in their slow, immense choreography. The sun is not a distant, unchanging lamp hanging in the sky, but an active, stormy, temperamental driver of the entire space environment our planet sits inside, constantly pelting us with light and particles and magnetic field, breathing its solar wind across us every second of every day. The atmosphere, the oceans, the crust, the deep metallic interior, the magnetic field that shields us, all of it is linked, some of the links blindingly obvious, and some of them still being painstakingly mapped by scientists right now. The honest scientific frontier is not about whether these systems connect. They obviously, undeniably do. The frontier is about which connections are strong, which are weak, and which ones we have merely imagined into being because our pattern-hungry minds wanted them there. So let me sort today's events into what we actually know versus what remains genuinely open, because that sorting, that discipline of putting each claim in its proper box, is the single most valuable thing I can leave you with tonight. On the solid ground side, the side of established, no doubt about it, science. Stress transfer between neighbouring faults, real and well understood, the reason we expect the Philippine and Manila trenches to be carrying a little more strain tonight than they were yesterday. The free oscillations of the Earth ringing like a bell after a great quake, real and routinely measured. Geomagnetically induced currents flowing through the ground and through our power grids during a storm, real, thoroughly documented, and a genuine and growing engineering concern for the infrastructure our entire civilization runs on. The Ring of Fire behaving as one stressed interconnected system, rather than a set of independent hotspots, real. Tsunami generation being governed by the depth and the style of a rupture, real, and the specific reason the Philippines was spared the worst today. The reason a coastline full of people is not counting a far darker toll. None of that is in doubt. All of it is ordinary, established, hard-won earth science, and all of it is genuinely remarkable when you stop to consider that we have figured it out at all. And then, on the open side, the one we have been circling all night long like moths around a porch light, whether the storms of the sun can actually modulate the timing of earthquakes here on the ground. That one is not settled, in either direction, and I want to resist the very human urge to pretend otherwise just to give you a clean ending. It is one of the quieter, stranger, more fascinating unresolved questions in all of geophysics, sitting right at the ragged edge of what we are currently able to measure and what we are able to prove. And today handed us about as clean an example of the open question as anyone could have asked for, almost as if to taunt us. A sun that had been erupting for days on end. 2 geomagnetic storms, one behind the event and a stronger one forecast for the very day of it. A particle enhancement that climbed steadily in the day before the rupture, matching, almost eerily, the one-day offset that proponents of the link insist should precede a large quake. And then, at the end of that whole sequence, the strongest earthquake of the entire year. Laid out like that, in order, it is almost too tidy, almost too perfect. And here is the thing, the discipline that this whole video has been building toward. The most honest, the most rigorous thing a scientist can do when staring at something that looks almost too tidy is to resist the tidiness, to refuse the easy satisfaction of it, and to say out loud, plainly, this is exactly what a meaningful signal would look like, and it is also exactly what a coincidence would look like, and I cannot yet tell which one I am looking at. Living in that uncertainty, refusing to collapse it prematurely just to feel better, is not weakness. It is the highest form of intellectual honesty there is. I want to linger on that idea of a coupled planet for a moment longer, because I think it is genuinely one of the most important shifts in how a person can come to see the world, and it has nothing to do with the unproven solar question at all. For most of human history, we experienced the earth and the sky as utterly separate realms. The ground was solid, permanent, the very definition of stability, the thing you stood on. The sky was a distant ceiling, a place of weather and lights and gods, untouchable and apart. And one of the quiet revolutions of modern science has been the steady erosion of that separation, the growing realization that the air and the ocean and the rock and the magnetic field and the sun, 93 million miles away, are all part of one continuous interacting system, that energy and matter flow between them constantly, that a flare on the sun can knock out a power grid in Canada, that a volcano in Indonesia can cool the entire planet for a year, that the slow churn of the deep mantle ultimately drives the earthquakes at the surface. We do not live on a stack of separate sealed compartments. We live inside a single, restless, interconnected machine, and we are only beginning, even now, to map all the gears. The solar earthquake question, whatever its ultimate answer turns out to be, is really just one more instance of this larger and humbling realization. The realization that the membrane between the sky and the ground is thinner and more porous than our ancestors ever imagined, and possibly thinner than we yet know. What about the days ahead? The practical reality. Here the ground is much firmer, because here we are back in established science rather than open speculation. Expect aftershocks to continue in the Philippines, the largest of them most likely landing somewhere around magnitude 6.8, and expect them to fade in both frequency and size over the coming days and weeks in that predictable decay. Expect the southern Philippines to stay seismically active and a little nervous for a while. Expect, through the ordinary and well-understood mechanism of stress transfer, somewhat elevated near-term stress on the neighbouring Philippine and Manila trenches, which were already restless before today, and watch them, because that is where the next significant event in this region would most plausibly come from, not from anything in the sky. Keep an eye on the sun too, because the active regions that produced this week's barrage do not simply vanish overnight, they rotate and they persist, and the storm cycle we are currently in has more to give before it quiets down. And if you are inclined to watch the stranger threads with a curious but skeptical eye, keep half an eye on the antipode, on South America, not because the alternating pattern is in any way proven, but because watching patiently over many events is the only honest way a pattern like that ever either earns belief or quietly falls apart under scrutiny. None of that watching requires you to believe the sun shook the earth. It only requires you to stay curious and to keep looking at the open data with clear eyes, because here is what I most want you to take away from all of this, and it is not a verdict, it is something more useful and more lasting than a verdict. It is a way of seeing. The value of a day like today is not that it answered the question. It did not answer the question, and anyone who tells you it did is selling you something. The value is in the practice of learning to hold two thoughts in the same hand at the same time without dropping either one. The timing is striking, and coincidence is the null hypothesis until it is genuinely beaten by evidence. A mind that can only hold the first of those thoughts becomes a believer in everything, seeing secret messages from the cosmos in every overlap and every alignment, drowning in false patterns. A mind that can only hold the second becomes incurious and brittle, dismissing every genuine mystery as mere noise and missing the real discoveries that hide inside anomalies. The trick, the actual hard-won discipline that this channel exists to practice, is to hold both at once, to let yourself be genuinely amazed by the alignment and genuinely skeptical of it in the very same instant, to feel the wonder and the doubt together. That is not a comfortable place to stand. The mind wants resolution, wants to pick a side and rest. But it is the only honest place there is, and I would rather stand somewhere honest and uncomfortable with you than somewhere comfortable and false. Which leaves us, at the very end, with one final question. And it is not really about the Philippines at all, as terrible and as real as the suffering there is tonight. It is about us, all of us, and the strange world we have built for ourselves. Part 9. The question that won't close. Strip everything else away, all the detail and all the data and all the careful reasoning, and here is what we are actually left holding at the end of this night. The strongest earthquake of the year arrived in the middle of a solar storm. It came after the sun had erupted for days, after a moderate geomagnetic storm 2 days earlier, after a flood of charged particles that climbed in the day before the rupture, matching the very one-day offset that some researchers insist should come before a great quake, and right as a strong storm was forecast to strike the planet. And the data, all of it, every instrument we have ever pointed at the sky and the ground, cannot tell us whether that means anything at all. It simply cannot. We are left standing in front of the question with empty hands. Sit with how strange that actually is, because it is stranger than it first appears. Not strange in the sense of supernatural, not strange in the sense of ghosts and omens. Strange in the sense that we have built over centuries an extraordinary machine of science. Satellites watching the sun around the clock, seismometers buried in the crust on every continent, solar telescopes and tsunami buoys and particle detectors and supercomputers. We have pointed this magnificent hard-won apparatus at one of the most basic questions a curious person could possibly ask. Did the thing in the sky have anything to do with the thing in the ground? And the machine, for now, with all its power, shrugs. It is genuinely uncertain. It cannot resolve the question. And that uncertainty, that shrug from our most powerful tools, is the actual terror at the centre of this story, far more than any single collapse building, as real and as heartbreaking as those collapses are. Because here is the real fear, and let me state it as precisely as I possibly can, because precision is the only way to handle a fear without either inflating it into hysteria or dismissing it into complacency. The real fear is not that the sun definitely shakes the earth. I have spent this entire video telling you, honestly, that this is unproven, and that on the current weight of evidence it is probably not the simple, dramatic story it sometimes gets made out to be. That is not the fear. The real fear is something subtler and much harder to shake off once you have felt it. It is that we live on a planet violent enough, and beneath a star active enough, that we genuinely cannot yet tell the difference between a message and a coincidence. We cannot tell, with all our instruments, whether the sky and the seafloor are speaking to each other in some language we have only half learned to read, or whether we are simply pattern-seeking animals staring at two restless independent systems that occasionally, inevitably, by pure chance overlap. And while we cannot tell, while that question sits open, we are busy building an entire civilization, vast power grids and constellations of satellites and undersea cables and gleaming cities of glass and steel, on the quiet, unexamined assumption that the ground beneath us and the sky above us will mostly leave us alone, will mostly behave, will mostly stay separate and predictable. And today, on opposite faces of the same small planet, in the same 48 hours, both of them declined to behave. Both of them reminded us, at the same time, how little we are truly in control of. And I think there is a reason this particular kind of uncertainty unsettles us more than most. We are, as a species, remarkably comfortable with dangers we understand, even enormous ones. We know hurricanes form over warm water, we know roughly where and when, we can watch them coming and get out of the way, we know which fault lines are dangerous, and we can, imperfectly, build for them. Understood danger, even severe danger, is something the mind can hold and manage. But a danger whose very nature is uncertain, where we cannot even say whether two things are connected, where the experts themselves shrug, touches a deeper nerve. It is the difference between a predator you can see and a rustle in the dark that might be a predator or might be the wind. The human mind handles the seen predator far better than the ambiguous rustle, and the solar earthquake question is, in a sense, the ultimate ambiguous rustle, a possible connection at planetary scale that we can neither confirm nor dismiss. That is why it gnaws. Not because the danger is necessarily large, but because the uncertainty is so fundamental, so resistant to our tools, so stubbornly unresolved. So which is it in the end? Maybe it is nothing. Maybe today was exactly what the cold mathematics of coincidence predicts, the unremarkable, statistically inevitable overlap of two systems that are each restless all the time, and we are simply reading a face into a cloud the way our minds have always done. That possibility should comfort you a little, and it should also unsettle you a little, for a reason that sneaks up on you. Because if it is pure coincidence, then it means the Philippines was simply due, the fault simply failed on its own grim schedule after a century of loading, and the striking timing with the sun was nothing more than a roll of the cosmic dice that happened to come up matching a meaningless and beautiful accident. Or maybe, and I say this with every ounce of the caution it demands, maybe it is the faintest edge of something real, a genuine connection between the star and the world it warms that we have glimpsed only in the statistics and never yet earned the right to claim, a thread of cause and effect too subtle for us to have proven but not too subtle to exist. And that possibility should unsettle you for the opposite reason, because it would mean the sun is not merely a source of light and warmth and the occasional disrupted satellite, but an active participant in the deep machinery of the very ground we stand on, a hand on the planet we never knew was there. Both possibilities should keep you up a little tonight for opposite reasons. They keep me up. There is a kind of courage in that, I think, that our culture does not talk about enough. We celebrate the courage of certainty, of conviction, of the bold claim and the confident answer. But there is a quieter, rarer courage in the willingness to stand in front of a genuine mystery and refuse to flinch toward a false resolution, to say I do not know and mean it, and to keep working anyway. That is the courage of real science, and it is the courage I am asking you to practice with me tonight. It would be so much easier to give you a clean ending, to tell you confidently that the sun shook the earth and send you off thrilled and certain, or to tell you confidently that it is all nonsense and send you off reassured and dismissive. Both endings would be lies, or at least claims far beyond what the evidence can support. The true ending, the honest one, is harder to sit with because it does not resolve. But I would rather give you a true discomfort than a false comfort, every single time, because the true discomfort is where real understanding eventually grows, and the false comfort is where it goes to die. The sky lit up, the seafloor tore open, they happened together, on the same small planet, in the same 48 hours, watched by every instrument we own. And the most honest thing that anyone alive can say about it, with all of that watching, all of that data, all of that hard-won science, trained on both events at once, is that we saw them happen side by side, and we still do not know if they were listening to each other. We do not know, and there is a strange dignity in being able to say that, clearly without flinching toward a false certainty in either direction. And maybe that is the right note to end on, the watching itself, because watching, real watching, is a quietly radical act. It is easy to look away from things we cannot resolve, to file them under unanswerable and move on, to let the discomfort of not knowing push us toward forgetting. But the people who actually move human understanding forward are the ones who keep watching the unresolved thing year after year, gathering the data event by event, refusing to either believe it into existence or dismiss it out of existence, just patiently accumulating the evidence until eventually the pattern either reveals itself as real or dissolves into the noise it always was. That is how every genuine discovery has ever been made, and it is how this question, the question of whether the sky and the ground are connected, will eventually be answered too, if it is answerable at all. Not by one dramatic night like this one, however striking. By 1,000 nights of patient watching, by people willing to hold the question open long enough for the planet itself to settle it. We are one of those nights. We added one data point to the long ledger, and the ledger stays open. The sun is not finished with us. Those active regions are still turned our way, still capable, still loaded. The aftershocks are not finished either. The ground in the Philippines still settling and shifting, the neighbouring trenches still loaded and waiting their turn, and the antipode, the far side of the world, has not yet given its answer. So we do the only thing that honest curiosity ever lets us do in the face of a question that refuses to close. We keep the instruments running. We keep both eyes open, the amazed one and the skeptical one at the same time. And we keep watching the sky and the ground and the unnerving, unresolved electric space in between them, where the answer, if there ever is one, is going to come from.